Welcome back to Upgrade to General, a series to help you upgrade your amateur radio license to General class. This is episode G2, Operating Procedures, and we're doing question group A. And I'm your host, Ron Call, KE7CR. I'm excited about this episode because we really are getting into how to actually do more on HF radio, which is my favorite part of ham radio. So let's jump in. First question is, which mode is most commonly used for voice communications on frequencies of 14 megahertz or higher? Let me give you a little background that'll help with lots of questions in this section. In order to transmit information on radio, you need a frequency that can be transmitted on an antenna that's a small enough size to be reasonable. We need radio frequencies, high frequencies, to do that in the megahertz range. But our voice and sounds, those are in the hertz to kilohertz range. Around 300 hertz to 3000 hertz for the human voice. But we need to somehow upscale that frequency into a radio frequency so that we can transmit it over the radio using an antenna that's a reasonable size. So to do that, we mix frequencies together. That's called modulating, mixing two frequencies. So we're going to take audio frequencies with our voice and combine them with radio frequencies. When frequencies are mixed like that, you get the original frequencies and the sum of those frequencies and the difference of those frequencies. Imagine if we combine a voice signal, say around 1 kilohertz, with another frequency high in the kilohertz or megahertz. Because the human voice consists of multiple frequencies, we're going to get multiple sums and multiple differences of those frequencies. So they'll span a range of frequencies. We call that a bandwidth. The original voice transmission mode was called amplitude modulation, or AM. And what it consisted of was a radio frequency called the carrier frequency. That was the frequency with which we combined the audio frequencies. So AM consists of a range of frequencies higher than the carrier and a range of frequencies lower than the carrier. The frequencies lower carried the same information as the frequencies higher than the carrier. So that mode is called amplitude modulation, because that's how the intelligence was encoded, was changing the amplitude of the signal. Or it's also called double sideband. Most of the time you hear AM, but it's also a double sideband. It included both sidebands. Now that mode was used for years and years, but it does have some drawbacks. It uses a large bandwidth, around 6 kilohertz of bandwidth, since the human voice occupies about 3 kilohertz. And you're using both sidebands, it would take about 6 kilohertz of bandwidth to transmit an AM signal. So in about 1951, a new mode was developed called single sideband. And essentially, one of the sidebands and the carrier frequency were filtered out, and only one sideband needed to be transmitted. And since a sideband by itself contains all of the information, then that worked fine. A real advantage of single sideband is that you can take the same power level, say 100 watts, and instead of spreading it out over 6 kilohertz of bandwidth, you'd spread it out over half of that, 3 kilohertz of bandwidth. So you effectively double your powers in that bandwidth. So that was a real advantage of single sideband. Now it doesn't really matter whether you use the upper sideband or the lower sideband, but back in the 1950s when single sideband was being developed, it was just less expensive to get parts and build a transmitter using lower sideband on frequencies below about 9 megahertz, and it was less expensive to get parts to build it for upper sideband above 9 megahertz. So that's kind of how they decided to divide it up. So nowadays that persists. Any of the HF bands below 20 meters uses the lower sideband. So 160 meters, 80 meters, 40 meters uses lower sideband. And 20 and above uses upper sideband. 20, 17, 15, 12, 10, all of those, and including the VHF and UHF bands, can use upper sideband. Now it's not a technical necessity. A transmitter would work with upper sideband on the lower bands, but by convention, everybody's just decided, you know what, that's the way it was done when it was first developed, we'll just continue doing it that way. So you're trying to use upper sideband on 80 meters or 40 meters or 160 meters, you're not going to get your signal through to people. They're not listening for the upper sideband, they're listening for the lower sideband. So by convention, that's how we do it. Okay, now with that background information, let's take a look at the questions. Which mode is most commonly used for voice communications on frequencies of 14 megahertz or higher? That's going to be upper sideband. Next question, which mode is most commonly used for voice communications on the 160, 75, and 40 meter bands? That's lower sideband. Next question, which mode is most commonly used for single sideband voice communications in the VHF and UHF bands? Again, upper sideband. Next question, which mode is most commonly used for voice communications on the 17 and 12 meter bands? Again, it's higher than 20 meters, so it's upper sideband. Which mode of voice communication is most commonly used on the HF amateur bands? It is single sideband. There are some frequency modulation. Some people still use AM or double sideband, but the most commonly used mode is single sideband. Next question, which of the following is an advantage of using single sideband as compared to other analog voice modes on HF amateur bands? By the other analog voice modes, they're really talking about AM and FM. And the answer is less bandwidth used and greater power efficiency. Next question, which of the following statements is true of single sideband? And the answer is only one sideband is transmitted, the other sideband and carrier are suppressed. The next question, what is the recommended way to break into a phone contact? When you're on the air and listening to people, if you want to break in and become part of the group or call someone, the way to do it is to just say your call sign once. And then if they come back with your call sign, then that's your invitation to break in and enter into the conversation. Next question, why do most amateur stations use lower sideband on the 160, 75, and 40 meter bands? It's just commonly accepted amateur practice. That's just the convention that everybody follows. It's not required, but it's commonly accepted amateur practice, and that's the answer. Next question, which of the following statements is true of Vox operation versus PTT operation? Vox stands for Voice Automated Transmission, and PTT stands for Push to Talk. Push to Talk just means you push the button in on the microphone, and then it starts transmitting. Vox is where it's using circuitry that picks up your voice and automatically triggers the transmitter. So the advantage of Vox is that it allows hands-free operation. Now you got to be careful with it, because if you inadvertently start talking, you're not intending to transmit, and it picks it up and transmits it. That can happen. So the answer is it allows hands-free operation. The next question, generally, who should respond to a station in the contiguous 48 states calling CQDX? DX means long distance. In this case, it would be meaning a foreign station outside of the lower 48 contiguous United States. CQ just means, hey, I seek you. I'm listening for, I want to talk to somebody. I want somebody to answer me. So when you call CQDX, you're asking for a long distance foreign station to answer. So the answer is any stations outside the lower 48 states. In the United States, Alaska and Hawaii count as DX because they're separated by such distances from the contiguous 48. Last question, what control is typically adjusted for proper ALC setting on a single sideband transceiver? ALC means automatic limiting control. For those watching the video, this is my transceiver, a Kenwood TS570.
CQ, 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 Kilo Echo 7, Charlie Romeo.
On the video I showed the mic gain and also the automatic limiting control. Purpose for ALC, or automatic limiting control, is to try to normalize the power level that reaches the final amplifying stage of the transmitter. So if you think about it, on a microphone you're going to have an amplifier to amplify your voice and feed that into the transmitter. Later on down the line in the transmitter, that's going to be amplified by a final amplifier stage before transmitting on the air. But if I talk too loud, if my mic gain is set too high or I talk too loud, that power level from the microphone may overdrive that amplifier stage. So an ALC circuit is as a circuit that automatically tries to limit or normalize the amount of power. So if you see that your ALC is constantly being pushed, it's working all the time trying to limit your audio, then the way to fix that is to lower your microphone gain To answer the question, what control is typically adjusted for proper ALC setting on a single sideband transceiver? It's the transmit audio or microphone gain. Alright, that's the end of this question set A. Hope this was helpful to you, and we'll see you next time for question set B. This is KE7CR 73.